An activity may be a task. It may be a sub-process belonging to a parent process where the sub-process may be formed of numerous other tasks at a more granular level. It may be a call activity, which would mean it is a global sub-process, often indicated in process diagrams with a thick border to what normally is indicated as a task. It may be an event sub-process, often indicated by dotted lines towards its borders. If it is interrupting, it is indicated by solid or continuous lines, and if non-interrupting, it is indicated by dashed lines. Next, we take a look at task types. Task types are modeled in a process diagram so that they remain executable within the process, which is undefined task. If it is a received task, it can be used in place of a catching message event. This is introduced in BPMN 2.0 notation. If it is a script task, it executes directly in the process engine. So a script task must be written in a language that the process engine can normally interpret while running the task. If it is a manual task, it is normally to be completed by a human being and is in no way connected to the tasks assigned by the process engine in an automation setup. So the manual task, there is a indication of a palm, and that basically distinguishes it from the other tasks. The receive instance or the receive task more or less replaces the message start event. Service tasks are done by the software. Normally, the engineers expect this to be offered as part of a service-oriented architecture in software engineering. Example may be credit rating provided by a rating agency over the World Wide Web. Next is user task. User tasks are normally executed by a human being, though it is assigned by the process engine. After finishing up execution, the human being is supposed to interact with the process engine by virtue of a button click or data share, whereby the process engine knows that the user task is complete. In other words, it is part of the human workflow management. Send tasks are normally executed by the process engine. So these are the different task types we have under activity. Next is an example of a loop task. So this type of task, what happens is that something goes on in a loop. So if you see, a timer event indicates that it is time for dinner and it's a start event. Now we get into the loop. Now there are a lot of people in the room and they are suggesting food. So that happens in a loop. Each of them, until everyone agrees, keeps on guessing or keeps on suggesting food, what needs to be prepared. So that becomes a loop task. Once everyone agrees, which is there is an association which actually indicates that everyone agrees what needs to be prepared, we get to the next task, which is prepare food task. Once the food is prepared, we get to the end task actually. So that is an example of a loop task. Next is an example of a multiple instance task. Here the start event is a none event where we actually say food being ordered in a shared apartment. Now there is multiple instance. What goes on in that task? It actually says it's again choosing food by inmates, but this time everyone in the flat should agree. So that is the example of a multiple instance task. It may also happen in parallel. Once there is an agreement, and it's not an agreement, once everyone in the flat chooses the food, we get to the next task, which is order food by filling in the online form placed at the website. Once that is done, food is made to order for delivery, which is the end task, and the order fulfillment has happened. So this is an example of a multiple instance task, which is indicated by a lot of straight lines in this portion of the task. Next is an example of compensation task. So now, what do you mean by compensation task? Compensation tasks are generally used for cancellation events. For instance, if we have a set of events in a process diagram that would be affected by, let us say, an event, those elements, whether they be events, activities, gateways or artifacts, can be grouped together under the compensation task, so that an unfavorable event may invoke a compensation which normally would cancel the effect or impact of the set of elements on the processes in general. So let us take an example here, the compensation task 1, which is about making trip allocations and booking. So that is the compensation task. Only catch is that if there is a consensus reached between members not to proceed with the trip, then the compensation task kicks in, and it actually says in the just below that compensation icon there is a cancel trip allocations. So if the consensus is against going for a trip, the compensation task kicks in and it would cancel all trip allocations in a manual loop compensation by calling the travel agent again and again until it settles. So this is an example of a compensation task in manual loop compensation. Another example of a compensation task is inviting all friends by means of a phone call, which if it goes on well, there will be a lot of friends coming because they are invited to the party. But if the compensation, if the invitation, if somebody decides that let's not invite anybody, then the compensation task kicks in, or the compensation factor kicks in, where there is a manual parallel compensation which happens of uninviting some by phone call. So that is the manual parallel compensation which actually happens. So that is indicated just below the compensation task.